In the previous topic, we talked about IPsec VPNs. Now, I will start DMVPN. First, I will cover the DMVPN theory. We will understand how it works, what's the addressing, what is underlay, what is MBMA, all this stuff. And we will continue with DMVPN phases. DMVPN is point-to-multipoint and multipoint-to-multipoint technology. So it's not point-to-point. Although in DMVPN phase 1, we will see there will be point-to-point, but that's why actually it's not scalable. In general, DMVPN can be used in very large scale design. So it supports multipoint to multipoint, which is full mesh generally topologies we can use. Basically two very well known and standard based protocols. There are RFCs for that. MGRE and NHRP comes together, and DMVPN we call it, okay? NHRP and MGRE, why they are used in DMVPN? NHRP is next hop resolution protocol, and as I said, in MGRE you don't have to configure the tunnel destination address, but how it will be known, how basically the remote endpoint address will be known. I said one of the technology is NHRP, and we will see now what is NBMA, what is underlay, what is tunnel and overlay in the topology, and it will be much clearer. But let me give you a little bit more explanation for this. MGRE, multipoint GRE, we talked about it, and tunnel interface doesn't require manual configuration. We have three different addressing, and with the picture, with the topology, I think it will be much more clear. The third one is local address. Here, physical and dynamic, and tunnel address. This tunnel address, like in GRE tunnel, MGRE tunnel, inside the tunnel. Physical address is real IP address. Think about you are running the DMVPN on top of internet, let's say. This physical address is real address. So on the internet, public address, right? And it is also called underlay address. It is also called NBMA address, non-broadcast multi-access address. So for the same meaning, we are using lots of different terms actually, but they are all the same. So physical address, public address also you can say, real address, NBMA address or underlay. And tunnel address is static basically, it doesn't change, and you configure on the SPOC and you configure it on the hub. Why NHRP is used basically? SPOC will tell to the hub what is my physical address and what is my tunnel address, their association to the hub, okay? This mapping from the SPOC to the hub basically needs to be sent into the NHRP messages. Now this, what is these tunnels, these yellow and green? Yellow between the SPOC and hub, and they are always up and running, okay? They are static tunnels, they are always up and running. Dynamic means if there is traffic between the spokes, they will come up. If there is no traffic, they will go down. So hub and spoke tunnels always up and running. They don't go down, right? Once NHRP finishes its job, they come up. It's not enough basically. Once these tunnels are up and running, somehow, as you can see here, 192.168.10/24, and here 2/24, 20/24, and here 300/24, right? These are LAN local area network IP addressing, and these IP addresses are advertised through the routing protocols. Once the DMVPN tunnels come up, these addresses needs to be sent, but with what? Routing protocols are used for this purpose. That's why DMVPN will be underlay, DMVPN tunnels will be underlay for the routing protocols. And routing protocols in DMVPN, why we use them? To advertise local area subnets. And dynamic unknown IP address, why it is unknown? Think about it. On internet, let's say some spoke sites, maybe they don't have static real IP address, static public IP address, right? On internet. So basically many ISP, they charge you for the static IP address. Maybe you have dynamic IP. With the dynamic IP still you can have DMVPN, because this dynamic IP, public IP and tunnel mapping is sent by the NHRP. If address change, NHRP basically sends another message and okay, my address is different and my tunnel address is this. Please register me. This message will be sent from the spoke to the hub and tunnel will come up again. Multicast is not natively supported with DMVPN. Okay, so there is an ingress replication. Still, multicast traffic can be sent from the hub to the spoke, for example, but there will be replication on the hub. What's the problem with the ingress replication and native support? Basically, on the hub, it causes more CPU and more memory utilization. So ingress replication is resource intensive process. Quality of service also is supported with the DMVPN. And good thing is, on the hub, per tunnel quality of service is supported. So different spokes might have different bandwidths, and hub needs to basically prevent the overutilization, the spoke uplinks. So that's why per tunnel quality of service is important. So the hub should behave differently for the spokes if they have different characteristics, like link speeds, if they have different link speeds, etc. Right? DMVPN is invented by the Cisco. The name actually invented by the Cisco, but same idea, multi-point VPN idea, basically is supported by the another vendors as well. Okay, with different names, but it's supported. And probably most people thinks that IPsec is mandatory with the DMVPN. It's not. It's optional. You don't have to have IPsec, but almost all deployments basically they commonly deploy IPsec with DMVPN. When the DMVPN tunnel come up, like the other mechanism GRE and MGRE, IPv4 and IPv6, unicast and multicast traffic can be carried through the DMVPN tunnels. That's important. It supports both IPv4 and IPv6, unicast and multicast. It doesn't support layer 2 protocols. It doesn't support non-IP protocols actually. It might be layer 3, but maybe non-IP protocol, right? And as I said, since it doesn't support layer 2, it cannot support ISAS as well. If ISAS will be used, you cannot deploy DMVPN. This is very important. DMVPN not only supports the routing protocol on top of the tunnels. DMVPN also can be created, those DMVPN tunnels can be created on top of IPv4 or IPv6 infrastructure. So you can have OSPF version 3 and you can have underlay infrastructure. On top of that, you can create DMVPN tunnels. And on top of DMVPN tunnels, you can run another IPv6 protocol. So these are all possible. There are different DMVPN phases. DMVPN phase 1, phase 2, phase 3. Cisco came up with the DMVPN phase 1 first. There was some problem with that. For example, the spoke cannot use MGRE tunnel, and there was no spoke-to-spoke tunnel. This was important, okay? There was no spoke-to-spoke tunnel with the DMVPN phase 1. That's why they considered that it was big business requirement. DMVPN phase 2 came up. DMVPN phase 2 was the first DMVPN phase which support spoke-to-spoke tunnels. So not only spoke to hub, which mean if one spoke site needs to send the traffic to the another spoke site, with the DMVPN phase 1, the data had to go through the hub and through the hub to another spoke. But with DMVPN phase 2, they came up with the spoke-to-spoke tunnel first, but there was another problem with the DMVPN phase 2 which we will see. And as we will see in the next video in DMVPN phases, control plane protocols always pass through the hub. So there is no control plane traffic between the two spokes, always through the hub.